I now need to introduce Shumon from Salesforce. Is going to tell us about and compare the various DNSSEC authentication denial of existence methods in use today.
All right, thank you, Kathy, and good afternoon, folks. There will be a tutorial on how to pronounce my last name at the end of the day. But you'll remain in mystery for now. Okay, so today I'm going to take you on a tour of authenticated denial of existence in the NSEC because it turns out over the course of many years it has become quite a complicated subject. Let me see if I can advance the slide. Good, all right. So first, what is it? It's how DNSSEC proves that a domain name or a record type doesn't exist. And there are multiple cases here where the domain name actually doesn't exist, commonly called NX domain, where a record type at a domain name doesn't exist, that's no data. And there are some specific subcases. So for example, if you have a wildcard match, you have to prove that the actually queried name didn't exist and that there was no closer match than the wildcard, and so on. All right, so the design of authenticated denial involves establishing a canonical ordering of all the names in a zone and the definition of a new record type, NSEC, that chains together successive names and also asserts which record types exist at the name. And a design of this sort is kind of needed for a DNSSEC because remember, DNS is not a point-to-point protocol. There could be many entities between the publisher of the data and the validating client. So simple channel protection or channel authentication is insufficient. Data needs to be authenticated, which leads to the NSEC record. Okay, so I'm going to illustrate the most basic form with an example. Here we see part of a zone where we have a name alpha.example.com, which has a couple of RR sets A and MX, followed by host.example.com with an A record. So the resulting NSEC record that chains these two together is at the bottom of the slide, alpha.example.com, NSEC, host.example.com, and the last bit is the type bitmaps, which shows which record types are available at alpha. Okay, so I'm going to skip over the no data example because it's easy and move on to NX domain, which is a bit complicated. So here we're trying to demonstrate that the name kk.example.test does not exist. And in the general case, you need two NSEC records to do this. The first one, the one at the bottom, covers the actual queried name to demonstrate that it doesn't exist because KK fits between JJ and NN. And the one above it is also needed, which covers the wildcard, which, if it existed, could have synthesized a response to that query. All right, so NSEC is NSEC3 is a modified version of NSEC, which addressed some of the limitations. The first is zone enumeration vulnerability, because if you chain all the names in the zone together, you can, by successive queries, figure out every name in the zone, right? And the second one is lack of incremental deployability. So there's a long, interesting history about how NSEC3 came about, including the preceding proposals like NSEC2 and DNS non-repudiation and something called opt-in, which were eventually combined to produce NSEC3. I'm not going to go into all those details other than to point out that some of the people involved in this effort are in this room, as is often the case at OAR conferences. I'm looking at David Black all the way back there, and I think Roy Aarons is here somewhere. I don't know where he is. But talk to those guys, and they can fill your ear about this subject. In the meantime, let's move on to some technical details. So NSEC is vulnerable to trivial zone enumeration, right? And then there's been a lot of debate in the community about whether we need zone enumeration protection because DNS data are inherently public. But I think it's important to realize that there is a crucial difference from being able to query an individual record and bulk disclosure of all the names in the zone, which frankly violates the principle of minimum disclosure. And in fact, there are many ccTLD registries that are under legal obligations to protect such disclosure. And if you've ever worked in a big tech company or encountered corporate security departments, you will quickly realize that they will not allow you to do this. And if you don't believe me, just try, All right? So NSEC3 attempts to address this problem by chaining together cryptographic hashes of the name in a zone rather than the actual names. So this raises the bar significantly for zone enumeration, but of course doesn't prevent it because the system is still vulnerable to offline dictionary attacks, which brings me to the next point. As a quick aside, the proposed NSEC5 protocol provably prevented zone enumeration by replacing the NSEC3 hash with a verifiable random function. So ultimately, this proposal did not have a traction in the IETF and was abandoned, but for the curious, I'm leaving some literature, presentations and papers. You can read about it if you're interested. But let's move on. The other important capability that NSEC3 provided was opt-out. So this allowed incremental deployability by allowing you to not include signed NSEC records into the chain for every record if you had a sparse zone with lots of insecure delegations. And I'll give you some information about deployment numbers later. All right, so quickly, what NSEC3 does is it hashes every name in the zone, sorts the hashes, and sticks consecutive hashes into NSEC3 records. I've shown a quick example at the bottom of the slide. The first hash on the first line is the hash of some name in the zone. The second hash on the second line is the hash of another name in the zone that's source app to the first hash. And there's the type bitmaps and a bunch of additional parameters like algorithm flags, iterations, and salt. Okay, so don't be alarmed by this slide, so I'm just going to go over it very quickly. So this is an example of how NSEC3 demonstrates an NX domain response. And as you can see, it looks a little bit complicated because it is. The details of NSEC3 proofs, and in general, the nuances of the protocol, are quite challenging to understand. So I remember Bert Hubert many years ago, shortly after he implemented in PowerDNS, he made a remark that the number 3 in NSEC3 stands for the number of people in the world that actually understand how it works, right? So obviously, that is an exaggeration, particularly when I'm talking to this audience, but the point he was trying to make is that even in the professional DNS community, it's very hard to find people who have a detailed understanding of NSEC3, okay? So very quickly, what you have to do, just the authoritative server side, to prove that a name doesn't exist, you have to produce 3 things. The NSEC3 record that covers the closest enclosing name to the non-existent name that actually exists in the zone. You need to produce the NSEC3 record that covers the next closer name, the name that you get by appending one more label from the Q name to the closest encloser, and the NSEC that covers the wildcard, right? So the rest of the details you can read in a 50-page RFC if you're interested. All right. So NSEC and NSEC3 both accommodate pre-computed signatures and online signing. And in this next slide, I've tried to contrast these two approaches. So pre-computed signing is generally more secure because the signing keys can be kept offline or at least on a much more guarded backend system. And they are more performant too because all the signatures can be pre-calculated. On the flip side, pre-computed zones are much, much larger, right? Because they have all the signatures in them. And generally, zone maintenance is much more burdensome because you need to keep refreshing the signatures as they approach their expiration, regardless of whether the data in the zone was actually created or not. You just have to do this constantly. And the other thing I'll point out is that dynamically generated responses, things like traffic management, those are generally much easier to implement with online signing, although they can be done with pre-computed signatures too. All right, so the other important variant of NSEC is what's called minimally covering NSEC, which uses epsilon functions to calculate a small NSEC range around the relevant domain name. And this effectively prevents zone enumeration because we aren't actually disclosing the before and after names in the zone, right? And this is also easier for some DNS implementations, which for whatever reason lack a zone data structure that allows them to efficiently compute the predecessor and successor names. These are deployed widely in the field in the forms of white lies and what used to be called black lies, but is now called compact denial of existence. So for NSEC white lies, I'll give you a quick example. So the non-existent name foo.example.com, the successor name is pretty easy to compute. You can just prepend a 0-octet label to the front of the name. The predecessor is a little bit complicated. If you want an accurate one, what you have to do is you have to decrement the ASCII ordinal of the last character of the first label and then pad out all ones to the full length of the label, right? So, but the thing I wanted to point out is that most implementations don't do this. Approximate epsilon functions are for all practical purposes for most zones good enough as long as you can ensure that an actually existing name doesn't fall into the approximate span. So I've given two examples at the bottom of the slide, which are approximate and easier to calculate. All right, by contrast, NSEC3 White Lies, the perfect epsilon function is much easier. All it is the hash of the name -1 and the hash of the name +1. I've given an example here, which I won't go through, but you can peruse it at your leisure later. The slides should be online. And let's go on to a more interesting development. So I think it was around 2016, Cloudflare came up with another clever way of doing authenticated denial of existence. And what they did was they answered queries for a non-existent name by claiming that the name actually existed. It just didn't have any data for the record types you're actually querying, for, right? And then this caused a little bit of a commotion at the time, right? Because I'm just going to paraphrase some of the shocked commentary heard. I'm not going to name who said this, but it was like this was described as an outrageous hack. It's also described, okay, there's no way the ITF should ever standardize this, right? And then this is, you can't suppress a critical signal like NX domain in this way. And it's true. If you suppress NX domain, that has a variety of impacts on all sorts of things like traffic characterization systems, a variety of security and analytical tools, etc. But the reasoning is that if you do this, you basically can minimize, you only need one minimal NSEC record. So you minimize both packet size and the computational costs of online signing. But whatever your views, hack or not, this is now widely deployed in the industry because other players have also adopted it. So it is quickly becoming one of the dominant implementations out there. So much so that it is actually, despite what I said previously, it's being standardized in the IETF. And the IETF is trying to repair some of the deficiencies by uncovering the NX domain signal in a different way, which I'm going to show you in a bit. So here's an example of what it looks like. So now all responses for non-existent names will return a no error answer, not an NX domain response code. And the authority section of these responses will contain a single NSEC record that matches the non-existent name. It has a minimal next name. And in the type bitmaps field, there is an extra synthetic, a pseudo record called NX name, which demonstrates that the name actually doesn't exist, right? So this is a way that you can clearly and conclusively distinguish it from things like empty non-terminals. All right, so I'm going to skip over this slide about hybrid modes, other than to say that they do work with some caveats. And we're going to take a look now about the state of implementation of these methods, first in open source authoritative server implementations. I looked at the big four, bind, NSD, PowerDNS, and NOT, and as you can see, all four of them support classic NSEC and NSEC3. The online and minimal signing modes are much less common in this class of software. PowerDNS does NSEC3 White Lies, and believe it or not, NotDNS, I found out very recently, does NSEC compact denial of existence. Although my understanding is there are not many users of these things in the open source community. Tell me if I'm wrong or not, but that's what I've been able to gather so far. Same chart, but for a set of commercial DNS providers. And here the interesting thing to note is almost all of them support only one mode. Okay, so that's all you get if you become a customer of one of these guys. The most dominant mode is compact denial of existence, supported by NS1 Cloudflare and Route 53. And I just learned at lunchtime, Azure, which I hadn't had time to test, they do this too. And there's even NSEC3 version of compact denial implemented by Oracle. This is also very recent. All right, let's switch gears to the topic of synthesis of negative responses. So this is also something that is very beneficial because it can reduce the overall load on the system by reducing the load both on the resolver side and the authoritative server side, because resolvers can suppress unnecessary outbound queries to authoritative servers. This can also help to mitigate the impact of many classes of denial of service attacks, like random subdomain attacks. The first one is straight NX domain synthesis, as described in RFC 8020. The spec allows synthesis from both signed and unsigned responses, but it advises caution for the unsigned case because what can happen is an adversary can spoof one response and cause a resolver to prune out a large subtree of their cache in one go, right? And if you can see from my survey of what implementations do, this caution is mostly heeded. None of the implementations I looked do it for unsigned responses. The open source ones all do it, and of the cloud providers that I looked at, only Google so far I've discovered that does this. The second one is described in RC 8198, aggressive negative caching. So this is where you can synthesize NX domain responses underneath not only the original name that elicited NX domain, but for any name that falls within the NSEC or NSEC3 span. Okay? So you can consider it a superset of 8020 for NX domain, but also you can examine the type bitmap in an NSEC record and do no data synthesis. And the third thing you can do is you can do wildcard synthesis, because wildcard responses also have a covering NSEC record from which you can figure out the scope of the operation, right? A quick survey of implementation support. As you can see from this chart, the open source implementations all do this for NSEC. In addition, Power DNS and Not DNS do it for NSEC3. Of the 3 cloud providers and 3 open resolvers and 1 cloud provider that I tested, only Google does this, but only for NSEC. When I spoke to some of the other folks, I got miscellaneous answers about why they don't do it. Some of them just haven't gotten around to it or don't consider this as important. But one of them explicitly told me that they are very wary of these techniques because of broken servers out there and what the impact is, which brings me then to the next point. It is a little bit perilous because the DNS ecosystem is very large and diverse, right? Even if it's in the minority, there are tons of broken servers out there that do not give the correct response all the time by the DNS protocol. I don't think I have to explain that to the people in this room, right? Or at least the people who operate DNS infrastructure. So there are things like servers that give quad A, NX domain for quad A, even though the A record of the same name didn't exist. That's wrong. There are CDNs that answer NX domain for intermediate labels in the name. That's also wrong. And there are implementations that cheat in how they populate NSEC and NSEC3 type bitmaps. I did a presentation 2 years ago that talked about a lot of these breakages and how they impacted my day-to-day operations. So you can read that if you like. And let's move on to some measurements. So I did a quick survey of the Tranco list of top 1 million sites. And the first observation I want to make is DNSSEC below the TLDs is quite sparsely deployed. So it's about only 8.7% of the top million. And did this advance? So I looked at those. So after pruning out the broken DNSSEC, I had 72,656 zones left. And of those, NSEC and NSEC3 are both widely deployed and use 59.5 and 40.5% respectively. Of NSEC, 3/4 of them are using online, minimally covering NSEC, probably due to the presence of a large number of small providers. Compact denial of existence is dominant. There's a sliver of white lies too. And NSEC3, most of it is classic, except for, I discovered recently, compact denial of existence. There's a small amount. I didn't know this until I did this study. And I'm almost approaching the end. I did also a quick survey of the TLDs. Here, the profile is a lot different as you might imagine. The prevalence of DNSSEC is very high. It's like close to 94%. And of those, NSEC3 is dominant at over 95%. And of those, 85% of those are using opt-out. So I don't know why exactly that is. So zone enumeration protection can't be the dominant reason for NSEC3 because most of the TLDs are generic TLDs, which are contracted parties to ICANN. They have to disclose it. So I suspect it might be opt-out. I'm not sure. It could be the default configuration of software that they use. So I'm only speculating. Maybe Roy at the mic is going to educate me in a minute. But I think I'm close to the end. I just wanted to acknowledge some of the folks that I talked to at various companies that helped me prepare the content of this presentation. And I am out of time, so I'll just leave this summary slide here and see what comments and questions folks have.
Thank you. Thank you. Thank you very, very much. Do we have questions? We do, at least two. Roy, go.
Roy Adams, ICANN. I understand NSEC3 and I understand NSEC and opt-out and all the good stuff. There's one question that I have for you.
Yep.
What is the perceived benefit of NSEC3 compact denial over NSEC compact denial?
Yep.
Since since you're not revealing anything that you already know with NSEC, with compact denial,
right.
Plus the extra hashing step seems redundant in that case. So explain like I'm 5.
Okay, yeah. All right. So that is a very good question. When this came up, I had the same question, and for the life of me, I don't know of a compelling reason to do it, right? So because there now is an implementation in the field, one of my plans is to track down some contacts at Oracle and find out what they perceived was the benefit. So the only benefit I can think of is if you had a pre-existing implementation of NSEC3 and you wanted to move to online signing, the delta is smaller than redoing your implementation in NSEC. So that is my only plausible benefit. There maybe I will be educated when I talk to these guys who have implemented it, though.
Thank you, Shumon. Great presentation. Thank you.
All right, thank you.
So Warren Kumari, Google, more of an update than a question. It was probably me who said that the compact denial of existence is an awful hack, but it's on the telechat in, I think, February 20th.
Yep.
And I mean, it should go forward. Just because something's an awful hack doesn't mean it's a bad idea.
I agree.
mean, everybody does it and it's useful. But
Absolutely, yeah. Sometimes you have to do hacks, right? And Warren, I'm willing to believe it was you did say that, but it was not only you. I have heard this from many other people. I won't name any other names, but talk to me afterwards.
My question was going to be, my back pocket question was, what was your stance on it?
My stance? Yes, no. I was horrified too, but now, fast forward, my name is the author on the draft, right? So it's like, why?
Okay, go.
Hi, Lars Lehmann from NetNode. It's an awful hack, but as such, it's a beautiful awful hack, so why not? Actually, I would like to comment on your previous slide there, where you had the numbers from TLDs there, yes.
TLDs? Okay. This one, yeah.
Yes. I think it would be more interesting to look at registries rather than the actual zones, because they're often lumped together with registries,
Okay.
and the same registry uses the same technology, I suppose. So that's probably a more interesting thing to look at. Thanks.
Okay, that's a great suggestion. Thank you, Lehman.
Hi, Dwayne Muscles from VeriSign. So in the middle of your talk, you talked about compact denial of existence and the NX name sort of restoring NX domain, basically. And I think you hinted that, again, like people in the ITF were horrified at the loss, or operators were horrified at the loss of NX domain. Are you aware of any managed DNS customers or registrants who are horrified by the loss of NX domain, or is it only purists?
I am aware. So I can speak from experience, Dwayne, because my day job, my employer, is one of those customers that was horrified, specifically me, and that's the reason I got involved in this, because as you remember, you might recall that there was a predecessor way to distinguish NX domain 2, which is the ENT distinguisher. I got one of my vendors to implement this because it was critical for some of our operational tools to be able to distinguish NX domain, right? That eventually turned into the NX name pseudo RR. So at the very least, there's one. I'm sure there's others.
Okay.
All right.
And kind of a follow-up question. Do you have any data on implementations of resolver software that restores, that reads the NX domain and restores the NX domain?
Okay, yeah. No, not yet. So this is a mechanism that is written, that is allowed in the draft. So far, I'm aware that Cloudflare colleagues have told me that they will implement it in their resolver. As far as I know, they haven't yet done it, but that's the only one that I know that has a plan to do it.
Thank you.
Yeah.
Petr Špaček, SC. I have a feeling that F5 is one of the other implementations which do NSEC3 minimal covering ranges.
Correct.
So you might talk to them as well, because I'm also interested in hearing why.
Why? Yeah. So NSEC3, Petr, so F5, you're right. So we use F5. They use NSEC3 White Lies, minimal signing. It's not compact denial of existence, it's white lies. So for the compact denial case that I answered, Roy, there is no compelling benefit that I'm aware of. But for white lies, there is, because NSEC, computing the epsilon function in NSEC3 is easy, whereas computing the perfect epsilon function in NSEC is harder. Maybe that's enough reason. I don't know.
Dave Black of VeriSign.
Yep.
Probably a question you don't expect. In your perils of, this is too tall. Okay, so in the perils of synthesizing NSEC or negative answers, you said people were wary of that because of broken things. Well, I know about those broken things, but I don't understand how they do that with DNSSEC.
You don't understand?
How do you answer NX domain for something with DNSSEC? You have to lie, right? You
have to lie, right? So you could do the compact denial of existence way of lying. That's a common way, but the most frequent breakage I've noticed.
But you can't use synthesis of negative answers with compact denial of existence because it doesn't tell you anything.
Right. Yeah. So the most common breakage, in my opinion, David, is no data synthesis, right? So you can lie about the type bitmaps.
Okay.
And validators don't care, because if it's not something they're looking for, it'll still pass validation, right? Except if you try to do no data synthesis.
So you can't really get away with like NX domain synthesis with DNSSEC.
Correct. Yeah.
You could get away.
Right, yeah. DNSSEC.
You could get away with. So the brokenness would be around the no data synthesis.
That's right. Yeah, but it impacts NX domain too, right? Because if you think about it, no data and NX domain have a connection depending on the ordering of queries, right? So you may query an NX domain below a no data, right? And that, if you have the incorrect type bitmap, then that name that existed no longer exists, right? I mean, I can show you some examples.
Okay.
It'll become clear.
This might be a discussion for afterwards. Okay, thank you very, very much to Shumon.
Right, thanks all.